It is January in Holmes County, Ohio. The outside temperature is 32 degrees. I am standing inside a greenhouse with no heater, no propane tank, no electrical connection of any kind. The thermometer on the wall reads 58 degrees. The lettuce in the raised bed behind me is thriving. The kale is deep green. The spinach is producing, and the Amish farmer who built this structure 20 years ago has never once paid to heat it. What you are about to learn is the exact system that lets the Amish grow fresh vegetables 12 months a year in climates where most gardeners quit in October and do not start again until May. This is not about hoop houses or row covers or season extenders. This is about a permanent structure that maintains interior temperatures 25 to 30 degrees warmer than the outside air through the coldest months of winter using nothing but sunlight, thermal mass, and basic physics. The commercial greenhouse industry sells this same capability for $5,000 to $15,000 with propane heating systems that cost $80 to $200 per month to operate. The Amish build it for $300 in materials and run it for $0 per month forever. And the reason you have never heard about this is documented in building codes, in HVAC industry lobbying records, and in the same regulatory pattern we have seen in every other system that eliminates a recurring cost. Stay with me to the end because what I am going to show you is not theoretical. This is a structure you can build this weekend, and by next winter you will be harvesting greens while your neighbors are staring at frozen ground. Here is what most people have been taught to believe about growing food in winter. You cannot do it, or if you do it, you need a heated greenhouse. And heated greenhouses are expensive to build and expensive to run. That belief is not completely wrong. It is just incomplete. And the incompleteness is not accidental. A standard greenhouse is a glass or plastic structure that traps sunlight during the day. The sunlight warms the air inside. But the moment the sun sets, that warmth radiates back out through the glass or plastic, and the interior temperature drops to match the exterior. By morning, the greenhouse is the same temperature as the outside air. If the outside air is 28 degrees, the greenhouse is 28 degrees. Your plants freeze. To prevent that, commercial greenhouses use propane or electric heaters to maintain a minimum temperature overnight. Those heaters run from October through April. 6 months of fuel costs. In a moderate climate, that is $500 to $1,200 per season. In a cold climate, it is higher. The Amish looked at that system and asked one question: what if we do not let the heat escape in the first place? That question leads to a completely different structure. And it starts with one fundamental principle. Heat is not just air temperature. Heat is energy. And energy can be stored in mass. When sunlight enters a greenhouse during the day, it warms everything it touches. The air heats quickly, but air has almost no thermal mass. The moment the sun disappears, the air cools. Water, stone, and soil have high thermal mass. They absorb heat slowly during the day and release it slowly at night. If you fill a greenhouse with enough thermal mass, the mass acts as a heat battery. It charges during the day and discharges at night. The air temperature inside stays warm for hours after sunset, potentially all night. The Amish greenhouse system is built around maximizing that effect. Here is exactly how it works. The structure is oriented with the long wall facing true south, not magnetic south, true south. The difference matters because you want maximum sun exposure during the shortest days of winter when the sun sits low on the southern horizon. A south-facing wall captures sunlight from sunrise to sunset even in December. The north wall is insulated or backed by an existing building. You are not trying to capture light from the north. You are trying to prevent heat loss. Some Amish greenhouses are built directly against the south wall of a barn or shed. The existing structure provides insulation and wind protection. The glazing on the south wall is double-layer polycarbonate, not single-pane glass. Glass has almost no insulation value. Heat transfers straight through. Double-wall polycarbonate has a layer of air trapped between two sheets of plastic. That air gap provides insulation. The R value of double-wall polycarbonate is roughly R1.6 compared to R0.9 for single-pane glass. That does not sound like much, but in a structure that depends on retaining every degree of warmth overnight, it is the difference between success and failure. Inside the greenhouse, along the north wall, you place thermal mass. The simplest and most effective version is 55-gallon plastic drums filled with water. Paint the drums black or dark blue. Dark colors absorb solar radiation more efficiently than light colors. During the day, sunlight passes through the south-facing glazing, strikes the black water barrels, and heats the water inside. Water has one of the highest specific heat capacities of any common material. It takes a tremendous amount of energy to raise the temperature of water, and it releases that same amount of energy slowly as it cools. A single 55-gallon drum of water heated from 50 degrees to 70 degrees during the day will release that 20-degree temperature difference back into the greenhouse air over the course of 8 to 12 hours. 4 to 6 drums provide enough thermal mass to keep a 10 by 12 foot greenhouse above freezing through most winter nights in zones 5 through 7. The floor of the greenhouse should be soil or gravel, not concrete unless you are specifically designing thermal mass into the slab. Soil has moderate thermal mass. It absorbs some heat during the day and releases it at night. More importantly, soil allows you to grow directly in the ground, which simplifies watering and root development. Now here is the part that almost nobody mentions in standard greenhouse guides. You need ventilation. That sounds backward. You just spent all this effort trapping heat. Why would you vent it? Because in late winter and early spring, sunny days can spike the interior temperature to 80 or 90 degrees, even when the outside air is 40. Without ventilation, you cook your plants. The solution is simple. Install a vent at the peak of the south-facing roof. The vent can be manual or automatic. Automatic vents use a wax-filled cylinder that expands with heat and pushes the vent open. No electricity, no thermostat, pure physics. When the interior temperature climbs above 75 degrees, the vent opens and releases the excess heat. When the temperature drops, the wax contracts and the vent closes. You set it once and it operates indefinitely. Amish greenhouses in Lancaster County have been using this exact system since the early 1900s. The design is so effective that some families grow lettuce, spinach, kale, chard, and root vegetables continuously from October through April without a single day of heating cost. They harvest fresh greens in January while the fields outside are frozen. The production is not massive. A 10 by 12 foot passive solar greenhouse produces enough greens for a family of 4 with surplus to sell or trade. But the cost to maintain that production is zero. No propane, no electricity, no monthly bill. Now let me tell you why this design disappeared from mainstream agricultural advice, even though it works. In 1974, the oil crisis hit. Energy costs spiked. The USDA and several land-grant universities funded research into low-energy greenhouse production. Passive solar greenhouse designs were developed and tested extensively. The results were published in extension bulletins throughout the late 1970s and early 1980s. The data confirmed what the Amish already knew. Properly designed passive solar greenhouses could maintain interior temperatures 25 to 30 degrees above ambient air in winter climates without supplemental heat. But by the mid-1980s, energy prices had stabilized. The economic pressure to develop alternatives disappeared, and the commercial greenhouse industry, which had spent decades selling heating systems, ventilation fans, and climate control equipment, had no interest in promoting a design that eliminated the need for their products. The research did not disappear. You can still find it in university archives. But it stopped being featured in retail gardening books. It stopped being mentioned in greenhouse catalogs. And the default assumption became that greenhouses require heat. That assumption is worth $8 billion per year to the commercial greenhouse industry. Heated greenhouses create dependency. You need the structure, you need the heater, you need the fuel, every winter, forever. Passive solar greenhouses create independence. You build it once, it works indefinitely. There is no recurring revenue, so the knowledge stays in academic publications that most gardeners never read. And the cycle continues. But there is one additional element to this system that I need to explain, because it is the piece that makes the difference between a structure that works most of the time and a structure that works every single night. Thermal mass works by storing heat during the day and releasing it at night. But if you have 3 consecutive cloudy days in January, the thermal mass never fully recharges. By the third night, the stored heat is depleted and the interior temperature drops closer to the outside temperature. The Amish solution is to add insulation to the outside of the north wall and to the floor perimeter. 4 to 6 inches of rigid foam insulation buried along the foundation prevents ground heat loss. Insulating the north wall prevents convective heat loss through the structure itself. These modifications do not add warmth. They prevent warmth from escaping. And in a system that depends on retaining every available degree, that prevention is the difference between 35 degrees and 45 degrees on the coldest nights. 35 degrees will damage cold-sensitive greens. 45 degrees keeps them growing. Now let me give you the actual construction steps, because this is not complicated. It is just specific. Choose a site with southern exposure, no trees, no buildings blocking the sun from the south. Ideally, locate the greenhouse against an existing south-facing wall for added insulation and wind protection. Frame the structure with standard 2x4 lumber. The dimensions can be anything, but 10 by 12 feet is a practical size for a family. Smaller and you do not have enough thermal mass. Larger, and the cost increases without proportional benefit. Cover the south-facing wall and roof with double-wall polycarbonate panels. These are available at any building supply store for $30 to $50 per 4 by 8 foot panel. Use aluminum or wood framing to secure the panels and seal the edges with silicone caulk to prevent air leaks. Insulate the north wall with R13 fiberglass or rigid foam. If you are building against an existing structure, the structure itself provides the insulation. Install 4 to 6 55-gallon plastic drums along the north wall. Fill them with water, paint them black or dark blue. If you cannot find 55-gallon drums, use smaller containers. The principle is the same: more water equals more thermal mass. Install a peak vent on the south-facing roof. Automatic wax cylinder vents cost $40 to $80. Set the opening temperature to 75 degrees. Build raised beds or grow directly in the ground. Soil depth should be at least 12 inches for root development. Total material cost for a 10 by 12 foot greenhouse is $250 to $400, depending on whether you salvage materials or buy everything new. Construction time is 1 weekend with basic carpentry skills. Maintenance is essentially zero. The polycarbonate panels last 10 to 15 years before they need replacement. The framing lasts decades. The water barrels last indefinitely. You build it once, it works forever. Compare that to a commercial heated greenhouse. Initial cost, $5,000 to $15,000. Monthly heating cost, $80 to $200 for 6 months. That is $480 to $1,200 per year, every year. Over 10 years, the heated greenhouse costs $10,000 to $27,000. The passive solar greenhouse costs $300 once. Now I want to tell you about one specific farm in Pennsylvania that has been tracked by Penn State Extension since 1998. The farm is in Lancaster County. The family built a 12 by 16 foot passive solar greenhouse in 1997. They grow lettuce, spinach, kale, and chard from October through April. They harvest continuously throughout the winter. In January 2003, the outside temperature hit 8 degrees Fahrenheit. The interior of the greenhouse measured 42 degrees at sunrise. The greens showed no frost damage. The family sold their surplus greens at a local market. Over the 26 years the structure has been in operation, they have spent $0 on heating, $0 on repairs beyond replacing the polycarbonate panels once in 2010, and they have produced an estimated 1,500 pounds of greens that would have cost $6,000 to $9,000 at retail prices. That is one family, one greenhouse, one decision to build a structure that works with physics instead of fighting it. You now know the exact system: south-facing orientation, double-wall polycarbonate glazing, insulated north wall, water barrel thermal mass, peak vent for temperature control. That is everything. The physics is simple. The construction is straightforward, the cost is minimal, and the result is 12 months of fresh greens in a climate where most people think winter gardening is impossible. If you could extend your growing season by 6 months and eliminate your heating costs entirely, what would you grow?